Now we have the camera data. According to our workflow, the next step should be processing the video data. However, from the developer's perspective, I would like to introduce in the next step how to give user feedback, because in this way, when we do something about the data, we get immediate check of our result, which is both benefit for the development and good for my role. The feedback method I will use is a little bit different from the most straightforward way of displaying something on iOS. The reason is, okay, let's talk about the display method I will use. Actually, I will allocate a three-dimensional rendering window, which is used to show computer graphics objects used in like game development to show our images, which is obviously an overshot. Actually, we will have a surface in the space and have the camera look at the surface and put the image we want to show on this surface. But in this way, we have great control on the raw pixels of the image we want to show, and also it will not be used in this project, but keep this in mind. In this way, it gives you another control of choosing the perspective of looking at the image, because a rich body of computer vision research is about to recover three-dimensional information from images. If we get the three-dimensional information and we want to visualize such information to the user, so employing three-dimensional rendering is a natural choice. We use import a framework called OpenGL kit. We will prepare an object to represent the display. Let's do it in a simple way called interface GL kit view response. We want our view, we want have control of the size of our view, and it is inherited from GLK view. There is a property atomic then called CG rect, which is a bound. Okay, this is a very simple object. The implementation does not contain anything. Response, right, clear everything. Now we have the window object ready. Let's fold this and give us more working space here. Let us prepare the object. This is called setup GLK view. GLK. We call this setup in the view did load callback. Setup GLK view. Actually, this can come first, because we can prepare our display before we actually access to the video data. There shouldn't be. Okay, the setup is a little bit complicated. You do not need to understand each step. As I said earlier, you can just follow the tutorial and let the understanding comes to you later. Or else, for the purpose of processing image and video data, you do not actually essentially need to understand this part at all. You can just copy the code from UDS Online and use for your project. CG React, that is to set up a frame. Equal to CG React make, that is to make a rectangle. The first argument is the x offset of the rectangle with respect to the entire view, and second is y offset vertically. I give it more space for the status display of the iPhone. Of course, in serious applications, you need more careful handling of those parameters, including the orientation of your device, the type of device, and well, whatever. This is the width. Width is called self. This self refers to the view controller. View controller obviously has a view, and the view get a bound. Size dot width, that is the view width. I'd like the frame to be 20 units smaller than the width, because we start from 10, and if we have 20 small, the width is 20 smaller, we have the 10 unit space on the left and the right, both on both sides. And the height, we can have it self.view.bounds size height. We give it more space in the vertical direction because you may want need to add some other elements like buttons or labels later, so I give it some 100 units more. Okay. Having set up the frame of our view, now we can create a view object. As we defined above, that is a GLK view with bounds. Call it feed view, because this view will be fed with camera data. The initialization is done using the GLK view response look, and we will call the base classes initialization method called init with frame. The frame is what we have set up above. And notice that here we need another argument. It is a context. A context, it is like an abstract layer of canvas for you to draw something, and the canvas is laid upon the physical device or physical surface, whatever. It is a good design that to separate your logic of drawing something from the actual physical device. So your application will be dealing mostly with context, and the context will handle all the brightness of a particular pixel, things like these details with the actual displaying device. Now we need a context. It's called EAGL context. It is an OpenGL context. Actually, this will be this is a property of a view controller. We will allocate it here. Property and non-atomic strong. It's EAGL context. So we give this context to this view. Context. Actually, I'm happy with this style. Okay. We do some setup of this view. Set display equals none. We give it a transformation. So rotation. We let it to rotate half pi. That is because we would like to use our app in a portrait orientation, but the image comes from the back camera will come in a landscape location, like your home button is on your right hand side. So we need to rotate the frame by counterclockwise by 90 degrees, which is half pi. Frame. This bind drawable prepares the context for all the following drawing operations. It needs to be called before we do any actual displaying operations. Next, we will set up its viewing bound. View dot view bounds equals like 0.0. This that is to use all the width of the frame of the view, and because we have allocated the video to be 640 by 480, and so the height would be 3/4 of the width. So we set up accordingly. Then we will attach this newly constructed view object to our main view. Add SubView this feed view. Lastly, let us keep a reference to this SubView in our view controller. Now we have our preview window prepared and the video session established. The next natural step is to connect these two parts of our application so that when the video data get updated, it will automatically call the display part, so that to do the displaying of the video data, of course, prior to displaying it. Later, we would like to add some processing module in it as well. Also, do not forget we have introduced an OpenGL context. We need to initialize the context when the view controller gets initialized as well. Now let's do the 2 steps next. Setting up the context is easy. As it's always here, give it void setup context. Let our EAGL context equals EAGL context log. Give some initializing parameter is API. Okay, so enables this to be rendered, this context to be joined using some set of API. We call it EAGL rendering OpenGL ES2. That is enough for our application. The connection between collecting video data and displaying and processing is done by a protocol of the video sample buffer output. In the output, we can add a delegate so that whenever the data is ready for the output, it will call the delegate to process, to display the data. In this simple application, we will use our view controller to implement the delegate protocol. Actually, is a delegate. Delegate is called AV capture video output sample buffer delegate. Okay, to implement the delegate, we add here so signature is output. If we capture output, look. I want to remind you, here I made a mistake that cost me something like an hour to find out. Because after I made this delegate, it works for a few frames and then stops working, and sometimes when I start the app, it doesn't work at all. It turned out that I have implemented the wrong delegate here. We should use did output sample buffer instead of this did job sample buffer. There is the signature of these two delegates are almost the same, and the workflow of them are almost the same as well. So when I put the operation which is meant for the output sample buffer into this job sample buffer, it works. When it works, it likes to work, but just the delegate wasn't called all the time. And because the signature of the two delegates are very similar, the compiler wasn't able to warn me anything. And then I googled, and there wasn't any runtime error either. I googled different kind of errors, but without luck. Eventually, I found I have I have linked to implement the wrong delegate. So, as you have seen my operation here, so the lesson might be to be careful and do not trust the autocompletion too much. Yes, this is what we need to implement this delegate. To verify the idea before we display anything in the delegate. Oh, the next step is to connect this delegate to the video data output we have set up here. Okay, video data output dot set. Oh, call method set simple buffer delegate. Okay, the delegate is the view controller itself, and remember the queue self.session queue. Now we suppose this delegate will be called each time the video data is ready. Let's have a check if this is the case. Delegate code, and well, we have an issue here. Oh, let's run. Right, here is the queue, but we haven't have the queue initialized. We need to do this before we use the queue, which is here. Session queue. Guess this page queue create. Give it some label. Hours session queue would be good. We do not need that pointer here. Let's try again. Okay, let's see. Before we use the display window to show the data and our processing results, let us first generate some dummy output to see if the drawing function works. The way to do that, the first step is, as we said above, use our preview views bind drawable to have the drawing context ready to accept our displaying instructions. And you need some manipulation just below this bind drawable for the self EA context. We need to ensure that our drawing context is now the current drawing context of the rendering engine, to see if the engine was busy with something else when in the time between the last call of this our display function and this one. So EAGL context, current context. If it is not, we set our rendering context, drawing context, the current one. EAGL context, set current context, our EAGL context. That's it. And now we display some OpenGL drawing function, which set up some clear color to clear the canvas. Okay, that is to be 0.5, 0.5, which is a gray area, and the transparent we set it to 1.0, which means it is not transparent at all. It will fill the display window. Now it is ready to clear our window buffer, the GL color buffer bit. Having cleared the drawing window, we can prepare for drawing the video data. But before that, let's check if it works. And now, having drawn it, we let the preview view display whatever we have drawn on the canvas, and click to run the program. If we open the app, it will show you a preview, which is not very much interesting, but at least we now have a canvas to draw our stuff.